One more problem. In quicksort, for sorting an elements, the n by 4th smallest element is selected as pivot. Okay. So somehow they are finding n by 4th smallest element and they are fixing it as a pivot using an order of n time algorithm. So what they are telling is, so we need pivot, right? To find out pivot, somehow they are using some order of n time algorithm and they are finding n by 4th. They are able to find out n by 4th smallest element in the list. Okay, it's good. Then what is the, if I use it as pivot, then what is the worst case time complexity of quicksort? We will see that. Let's do that. Example, X is such an element. What happens after partitioning? We know that there are 3 steps in partitioning, correct? Partitioning, first step, partition, second step, quicksort on first partition, third step is quicksort on second partition. So if I execute this partitioning step, before that, fixing the pivot, right? Selecting the pivot takes order of n time, plus running the partition takes order of n time. We know that, correct? Because of that, X will sit in exactly a position which is nothing but n by 4th position in the order. Then we have approximately n by 4 element this side, 3n by 4 elements this side. Then we are going to run quicksort on this n by 4 approximately and 3n by 4 at right side. Then what is the total time complexity? Let's say total time complexity of any recursive algorithm can be, calculated using recurrence relations. So T of n equal to first step, finding pivot, order of n. Let's write n plus partitioning n units plus applying quicksort on n by 4 elements. So again, here also we will be doing the same thing, finding pivot with, so we are using again pivot which is n by 4 smallest and same story. That's why quicksort of n by 4 elements with same set of steps takes T of n by 4 time according to recurrence, plus quicksort of 3n by 4 takes T of 3n by 4. So total time complexity, if you see, T of n equal to T of n by 4 plus T of 3n by 4 plus 2 into n, correct? But we never solved this kind of recurrence relations. So always we solved, in divide and conquer, we know that recurrence relation model is A into T of n by b. Always we should have A problems and each of size something n by b. But here we have a size of n by 4 1 and 3n by 4 1. Then how to solve it? See, recursion tree method. So using that I am going to solve this one. Your recurrence relation is T of n equal to T of n by 4 plus T of 3n by 4 plus n, right? C into n. So what we do is, we try to draw the tree for this recurrence relation. So how I do, I will tell you. Example, your recurrence relation is like this. T of n equal to T of n by 2 plus some C into n. Then I can understand that the value of T of n is Cn plus the value which is given by T of n by 2. Then I can write in this tree model Cn plus value which is given by T of n by 2. But value which is given by T of n by 2 is what? According to recurrence relation, T of n by 2 equal to T of n by 4 plus C into n by 2, correct? So that's why I write here Cn by 2 plus value which is given by T of n by 4, correct? In that way we can draw the recurrence tree. See, Cn plus Cn by 2 plus value which is given by T of n by 4, I can extend it. In the same way I am going to extend this T of n by 4 plus T of 3n by 4 recurrence relations recursion tree. First, so T of n is the thing, correct? So in this one, what is the value we have? Cn plus value which is given by T of n by 4, I don't know, let's write T of n by 4 plus value which is given by T of 3n by 4, let's denote it by T of 3n by 4. Now, how much value is given by T of n by 4? Let's write recurrence relation and understand. T of n by 4 equal to, see, problem equal to problem by 4 plus 3 into problem by 4 plus Cn, correct? Then this will be T of n by 16 plus T of 3n by 16 plus C into n. N is here n by 4, correct? So T of n by 4 is giving us C into n by 4 plus 2 extra things, correct? Let's denote it. So here T of n by 4 gives, I am replacing T of n by 4 with Cn by 4. Directly it is giving Cn by 4 plus 2 more extra. So we know what are they, right? Which are nothing but value which is given by T of n by 16, value which is given by T of 3n by 16. Similarly, I can replace this value. T of 3n by 4 is nothing but, here you get C into 3n by 4 plus value which is given by T of 3n by 4 which is nothing but 3n by 16, correct, and value which is given by T of 3n by 4, so 3 by 4th of n. What is n here? 3n by 4. 3 by 4th of this n, 3n by 4, which would become 9n by 16. So now slowly you can understand that this is Cn. We have now, because of these two, Cn by 4, C3n by 4. In the next level we have Tn by 16, T3n by 16, here T3n by 16, T9n by 16. So Tn by 16 can be replaced with, its value is Cn by 16 plus two other things. So T3n by 16 will be replaced with what? T of n is replaced with Cn plus some other things. Similarly, 3n by 16 will be replaced with 3n by 16 with two other values which are given by other recurrent relations. So here T of 3n by 16 can be replaced with what? 3n by 16 plus two extra values. We know that. So here T9n by 16 can be in the same way replaced by 9n by 16 plus two extra things. So this is nothing but Cn by 64. This will be 3 by 4th of this one. 3 by 4th of this one is C into 3n by 64. This will be again 1 by 4th, 3n by 64. This is 3 by 4th of this one, it will be 9n by 64. This would be 1 by 4th of this one, it would be 3 by 64 of n. 3 by 4th of this one is 9 by 64 of n. Here 1 by 4th is 9 by 64 n. Here 3 by 4th is 27 by 64 of n. In that way, still it will be continued. Now, we are not drawing the complete tree because we don't know how many levels it will go. But if you see, total answer is Cn plus these two plus these are all plus these are all. Let me count level by level. In the first level we have Cn. In the second level we have Cn by 4 plus C into 3n by 4, which is nothing but 4n by 4 into C, which is again C into n. Now if you see in this level, let me take C common and by 16 common. If I take C by 16 and n also common, what you get? We have 1 plus here 3 plus here 3 plus here 9, correct? So we have finally 4. 9 plus 3 12, 12 plus 3 15, 15 plus 1 16. 16 gets cancelled, you get again Cn. So in the same way you can understand here, this entire sum will become 27, 36, 45, 48, 57, 60, 63, 64. 64 gets cancelled, again you get Cn. What I want to say is, in the every level you are getting Cn, right? How many Cn's you get is a question. But after some time what happens, I will tell you. Now this side if you see, it will be Cn will become C into 3n by 4, after that C into 9n by 16, so on. This side is shorter than this side, correct? Why? Because if you take n value 100, then 100 is becoming 25 this side, but this 100 is becoming 75 because we are doing 3 by 4th. Then again 75 will be, this side it will be 1 by 4th of 75, it will be 3 by 4th of 75. Then this 25 will be 1 by 4th of 25 this side and 3 by 4th of 25. So if you go this side, then quickly your tree will be going to be terminated. Otherwise I can say number of levels or depth of the tree this side will be smallest, right? So what is the smallest depth of the tree is important for me. Why? I will tell you. See, everywhere if you have two nodes like this, all the nodes, okay, let's say your tree is not terminating, that means every level you have nodes, but that is not the case. After some time, so this will be terminated, but still these nodes will be still expanded, but it will be terminated because it will reach 1. Understand? Example, let's say you have 16. 16 problem will be divided into n by 4 and 3n by 4. What is 3n by 4? 3 by 4th of 16, which is nothing but 12. Then 4 will become 1, so it will be terminated, it will reach base case, and this side 3 by 4th of 4, 3. But 12 by 4 is 3, 3 by 4th of 12 is 9. Still this tree will be expanded maybe, correct? Then if that is the case, if every level if you have full nodes like this, then only this is going to be Cn, correct? Our observation is, if everywhere you get, here if you get value, here you get value, that is going to be Cn. Here, everywhere if you get values in this level, then it is becoming Cn. But that is not always the case. After some time, you will have values this side of the tree, but not this side. Then the overall value cannot be C into n, it is less than Cn. That is what happening here. Example, here you have Cn. Here you have Cn, see, 16. 12 plus 4, 16. 9, 3, 3, 1, 16. After that next level you will have values here only, but not here. So that this overall value cannot be 16, correct? So that means Cn is not every time, only sometimes. But how many times you get Cn? That means how many times I can take Cn from the tree? You can take Cn only till this level is, this side height is not completed, correct? So that's why I will see first of all height of the tree, otherwise shortest path at this side, otherwise path of this length. We will see that. How to find out path of this length? I do here. See, initially you have Cn, correct? I am just going leftmost. So Cn by 4. Next Cn by 16. That Cn by 16 will become Cn by 64. So on. After that it will become 1 suddenly. When it will become 1, if you see Cn n by 4 by 4 by 4 by 4. Every time you are doing by 4. You remember one thing, one shortcut. Whenever you have some value k, every time if you do k by 4, like every time if you divide by 4, after log k base 4 iterations approximately, this k is going to be 1, remember. Example, if you have a value k, every time if you divide by 2, like k by 2, k by 4, and after some time if it becomes 1, then if you want to know the number of iterations, like how many steps we have to do, that is exactly log k, because you are dividing by 2, it is log k base 2. Here every time you are dividing by 4, then it is log k base 4. That's it. So if you follow that technique, you understand that it is log Cn every time you are dividing by 4. That's why after log Cn by base 4 iterations, this is going to be terminated. That means that many steps you will have. So each step represents, these all the steps represent the depth of the, otherwise length of this path, correct? I want length of this path. One more way of finding that length of the path I will tell you. Cn by 4, Cn by 16, Cn by 64. After some time it will become Cn by 4 power k, correct? We want to find out k value. How to do that? I will tell you. Cn by 4 power k, if you see the leaf, that leaf will be a node. What is leaf in this problem? Whenever you reach base case, that means base case is nothing but you have t of n problem. So t of n will become t of n by 4. Suddenly it will become t of 1. Then we stop it, correct? So what I want to say is, this is going to be 1. Then we stop it, correct? Cn by 4, after suddenly it is 1. Cn by 4 power k equal to 1, we stop it. Then what is k value? Then Cn equal to 4 to the power of k, but I want n value, right? K value, right? Then I apply logarithm. Log Cn base 4, if I apply, it will be, I am applying logarithm base 4. Log 4 power k base 4. It would be k log 4 base 4, which is nothing but k, equal to log Cn base 4. That is what I said. When you have initially Cn, if you divide by 4 by 4 by 4 every time, it will become 1 after log Cn base 4 iterations. That means k is, let's say, number of iterations. So now finally you understand that the number of iterations or number of levels at this side, if you see left side, leftmost otherwise, is log Cn base 4. That is very important figure. But at least these many times, see, this is the termination point of this, in this level or this side. Then still other nodes will be in this level, all the nodes will be present. Why? Because see the observation, 100 is becoming 25 this side, 75 this side. This side you have more value, then that will not be terminated. That means that will not be consumed completely, correct? But this side will be consumed quickly whenever this is the last point in this side, then still other levels will be still existing, right? Completely. So what I want to say is, there are at least log Cn by 4 levels where your tree is full, complete. So if it is complete, then every level gives Cn. There are log Cn by 4 complete levels. Every level gives Cn. Then how much value you get? Cn into log Cn base 4 plus remaining thing. Remaining thing I don't know, because remaining thing is highly variable. Suddenly after that some nodes will be terminated. After that in the next level few more nodes will be terminated. That's why better you leave it, not a problem. So now I can say that our time complexity is Cn into log Cn by 4 plus something extra. Now in the options, if you see, we have theta of n, right? Theta of n log n, something like this, correct? Something. Now how can I say that answer is n log n? I will tell you. If I only compute this one, it is finally you can decide that your answer is definitely your T of n is with this value, with extra is also there, right? Some extra. I can say that T of n is definitely more than this. So remember, your answer T of n answer is greater than or equal to Cn into log Cn by 4. Remember it. Now if I assume every level 3n by 4, that means let's say nothing is terminating, then what happens? Let's say this is I assume that let's say this is longest, okay, but this is going to be terminated after some time. When it will be terminated, we'll see. The longest path will hold, or the longest path I'm calculating the length of the path. Initially you started at Cn is becoming C into 3n by 4. Next time it is becoming C into 3n by 4, n is common, this will become 9 by 16, right? Next time it will become Cn into 27 by something 48. What can I understand is every time you are dividing Cn by 4 by 3, correct? See, Cn. This is 3n by 4 means what I can say, it is Cn by 4 by 3. Next time it is Cn divided by 4 by 3 whole square, in that way. It is Cn divided by 4 by 3 whole cube. That is what I understand with this. 464 by 27. Now what I want to say is, already I told you, every time if you divide some Cn by 4 by 3, after how many iterations that will become terminated? Definitely log Cn base 4 by 3. So now what I want to say is, if up to this level, this is longest level, up to these many levels, still all other nodes also, let's say, existing. That means if you understand that, otherwise if you assume that this is longest path, in this longest path still this level, if all the nodes are present, then every time you get Cn, correct? Cn, every level Cn. If you count Cn these many times, what it become? Cn into log Cn, again base 4 by 3, correct? So 4 by 3 is some constant base. We can ignore that base. It is again Cn into log Cn. So what I want to say is, of course, but this is wrong answer, because up to these many levels we don't have Cn values, correct? Only up to that shortest level only we have Cn values. So what I want to say is, if I exaggerate the answer also, then you are getting Cn into log Cn, correct? If I reduce the value, if I take lower bound, it will be again Cn into log n, correct? So then definitely I can say that my answer is in between these two. So approximately lower bound also Cn log n, upper bound also Cn log n. So what is lower bound? I am just assuming that taking shortest path, that means only that many levels I am taking. Example, shortest path is 10, then only 10 levels I am counting. Only that 10 levels contribution if I take, that is lower bound. Now I took upper bound also, then lower bound I got Cn log n approximately asymptotically, upper bound also I got Cn log n. So that's why your answer is between lower bound and upper bound, which is nothing but asymptotically Cn log n. So this problem's time complexity Cn log n.